So this problem is the same as the last one we did. It's still taking implicit differentiation. The only difference is we are finding the derivative at a point now. Okay, before we used to take the derivative at like x equals. Well, now it's more specific because we have x's and y's in our problem. We're finding it at a specific point. Okay, so we are finding dy dx, so that means I got to take the derivative of this thing. So let's do that. It starts off by saying 2x plus y all squared. So, Selena, what do you think I'm going to have to do there to take the derivative of it? Chain rule. Very good. I'm going to take the derivative. So it's going to be 2 out in front. Take the derivative of the outside. So I multiplied by 2. And I'm going to decrease the exponent so it's just 1. And then what, Selena? Rewrite the baby. Rewrite the inside. And from there I'm going to derivative of the inside. So I'm going to multiply by what here? 2. So the derivative of 2x is 2. And the derivative of y is dy dx. Good. She just fixed it because I was getting ready to tell her she was wrong. But she said we need to put that in parentheses. Anytime we multiply by a derivative and it's more than one part, don't forget the parentheses. It's like the number one mistake. Good. That is the chain rule. All we did was just take the derivative of that thing. That was chain rule. Okay. Then I've got this next thing, Hannah. What's the derivative of plus y going to be? The derivative of y is just dy over dx. Okay, and then the number one mistake in these problems. What's the derivative of 3 going to be? 0. Don't do that. It's just 0. It goes away. All right, I have to color code because this bothers me. Make that all black, please. And then we go back. Nope, nope. Oh, no. All right, there we go. That's what I wanted. I'm going to make that red, please. And make that red. Nope. Nope, nope. There we go. Okay, so I'm trying to make you visualize what we're looking for. We're trying to get dy dx by itself. Okay, that's the important thing here. Is it going to be fun to get dy dx by itself here? No, because I really can't move anything over. I'd have to factor it out, and it'd get really yucky. All right? If you're taking the derivative at a point, you don't have to. You don't have to get dy dx by itself yet. Instead, let's make it simpler by plugging in my x value. X is 1, so where I have an x, I can plug 1 in. And where I have a y, I can plug in -1. So let's do that. So now my problem is going to be 2. And instead of x, I can plug in 1. Plus y, and instead of y, I can plug in -1. Times 2 plus dy dx plus dy dx. Okay, so all I did was plug in, and I'm going to try to simplify. Well, I've got 2 times 1 minus 1, so that's 2 minus 1, or 1, times 2, which is just 2. This whole thing just became 2. Way easier problem now. Bless you. What else can I do to simplify this thing? Distribute the 2. I've got a 2 in front. So I can multiply these two things by 2. And I get 4 plus 2 dy dx plus dy dx equals 0. Now it's going to be a whole lot easier to get dy dx by itself. Okay, what could I do from here? Subtract 4. I've got this 4 right here. Super. I'm going to subtract it to get it to the other side. We also need to simplify this thing. Okay? Let me use real life language. You have 2 apples, and you're adding that to 1 apple. How many apples do you have? 3 apples. That is what this says right here. You have 2 dy dx's, and you got another dy dx. How many dy dx's do we have? 3. It's just combining like terms. Okay? Don't let that scare you just because it's got dy dx and not apples written down. Okay? It is 3 dy dx. So if I'm looking to solve this problem for dy dx, what do I still need to do? Divide by 3, divide by 3. There is my answer. dy dx is -4/3. So again, we took the derivative, and if you're finding at a point, as soon as you do the calculus, as soon as you get to this step right here, okay, that's when I want to plug in 1 and -1 right away. That way the numbers are easier to deal with. You don't have the crazy x's and y's going on.